Hello and welcome to the channel. This system of three simultaneous equations looks scary. Nevertheless, it has a short and elegant solution. That's the reason why I like it, and I hope you will like it too. For someone who might be unfamiliar with that, GDR stands for German Democratic Republic, Deutsche Demokratische Republik, commonly known as East Germany, where the national mathematical competitions, named Olympiaden junger Mathematiker, translated as Olympiads for Young Mathematicians, took place starting from 1962. As a hint, the task is intended for years 11-12, as the solution uses something the junior year students may be unfamiliar with. Here you can pause the video and try to figure out the solution. Since the domain is not specified explicitly, we assume that x, y, and z are real numbers, as there is nothing that seems to reduce this domain. Take the first equation of the system, I will copy it for convenience, and move the second term to the right-hand side. Then we can factorize the right-hand side by taking out the common factor y. Before we obtain the expression for y, we have to make sure that factor 1 minus x squared is non-zero. Indeed, if 1 minus x squared is 0, then the equation gives 2x equals 0, so x equals 0. However, if x equals 0, then 1 minus x squared must be 1, while we assumed that it is 0. This contradiction shows that 1 minus x squared is non-zero, so we can divide the equation by 1 minus x squared to obtain the expression for y in terms of x. The other two equations of the system look very similar, and a similar approach can be applied to them. This brings up a system of equations equivalent to the original one. We see that the right-hand sides of the new system of equations have the same type, 2t divided by 1 minus t squared. Doesn't that look familiar to you? If this still doesn't look familiar, consider replacing t with tangent of alpha. Hopefully the new expression will ring the bell to anyone familiar with trigonometry, because this is exactly tangent of 2 alpha, what a textbook calls tangent double angle identity. To use the identity, we need the following substitution: phi equals arctangent of x. According to arctangent definition, x equals tangent of phi, while the value of phi is more than negative pi over 2 and less than pi over 2. Since arctan function is defined for any real argument, such a substitution does not reduce the domain. Let's substitute tangent phi for x into the first equation of the system. We get y equals 2 tangent of phi divided by 1 minus tangent squared of phi. Applying tangent double angle identity gives y equals tan of 2 phi. Now we've got an expression for y, which can be substituted into the second equation of the system. And we get the expression for z. And again apply tangent double angle identity, and substitute the obtained expression for z into the third equation of the system. And we get the expression for x. And for the third time we apply tangent double angle identity. And we substitute. No, we can't, because there are no more equations in the system. But hold on, we had another expression for x. X equals tan of phi, while the new expression is tan of 8 phi. Can we avoid this ambiguity? Yes, we can, by just assuming that tangent of 8 phi equals tangent of phi. This is an equation for phi, and we need to solve it. To do that, we rewrite it as tangent of 8 phi minus tangent of phi equals 0. Then apply another trigonometric identity, this time for the difference of two tangents. For someone unfamiliar with it, that's how simply it can be proven. We just write tangent alpha minus tangent beta, rewrite each tangent as sine over cosine, reduce to the common denominator cosine alpha times cosine beta, and get exactly sine of alpha minus beta in the numerator, which completes the proof. Applying the identity to the left-hand side of the equation, we get sine of 7 phi divided by cosine of 8 phi times cosine of phi equals 0. Therefore, sine of 7 phi equals 0, 7 phi equals pi times k, where k is an integer, while phi equals pi k divided by 7, where k is an integer. However, not all values of phi apply to the solution, as we need phi to be more than negative half pi and less than half pi. In other words, the absolute value of phi must be less than pi over 2. So we get the equation absolute value of pi k over 7 is less than pi over 2, from which we find that the absolute value of k is less than 7 halves, or 3.5. Given that k is an integer, the absolute value of k is no more than 3. Substituting the values of phi into the expression for x, we get x equals tangent of pi k over 7, where k equals 0, plus minus 1, plus minus 2, plus minus 3. Then from the expression for y, we find y equals tangent of 2 pi k over 7 with same values of k. And from the equation for z, we find z equals tangent of 4 pi k over 7. And we need to ensure that all tangent values are defined, because as opposed to sine and cosine, tangent value is not always defined. This happens because tangent is actually sine divided by cosine, and when cosine is 0, the result is undefined. Solving the equation cosine of alpha is 0 gives alpha equals half pi plus pi times n, where n is an integer, and after reducing to common denominator and taking out common factor pi, we get alpha equals pi times 2n plus 1 divided by 2, where n is an integer. Testing each value of x, y, and z would be rather boring. However, there is a trick that allows doing that immediately. It can be noticed that any value of x, y, or z can be expressed as tan of pi times m divided by 7, where m is an integer. Therefore, if tangent is undefined for a certain m, we must have pi times m over 7 equals pi times 2n plus 1 over 2 for certain integer values of m and n. In this case, m equals 7 times 2n plus 1 divided by 2. However, since both 7 and 2n plus 1 are odd numbers, the numerator in the right-hand side is an odd number. Therefore, the right-hand side is a fractional number, while the left-hand side is an integer. This shows that there is nothing to be discarded. All 7 triplets of x, y, and z satisfy the given system of simultaneous equations. So this is the solution. And this is the end.